Before we dive into this Python program, let us first explain what heat capacity is. Heat capacity is the amount of heat energy required to change the temperature of a substance. More specifically, specific heat capacity is the heat needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius.
This property is crucial in chemical engineering where temperature control directly affects reaction rates, product yields, and safety. Whether you're designing heat exchangers, analyzing reactor performance, or simulating cooling systems, you need to know how substances absorb and release heat.
That's where SPeC comes in. It is a lightweight Python tool designed to help students and even professionals to calculate specific heat-related variables quickly and accurately. Instead of manually solving formulas each time, SPeC guide you through inputs while also giving you clear and reliable results.
Now let's take a look at the core concept behind SPeC, the specific heat capacity formula, where C is the specific heat capacity in joules per gram per degree Celsius or joules per kilogram per Kelvin. Q is the heat energy in joules. M is the mass of the substance in grams or in kilograms. And delta T is the temperature change in degrees Celsius or in Kelvin. This equation tells us how much energy it takes to raise a material's temperature. In SPeC, this formula is at the heart of the program. The program rearranges the formula automatically and computes the missing value, saving time and reducing the chance of manual calculation errors.
Welcome everyone to SPeC, your specific heat calculator. Let us explore the feature and functionality of the school Python console program.
Our program all starts with a choice. Once you run SPeC, you're greeted with a neatly displayed table showing the 40 variables related to specific heat capacity. Heat energy represented by T, mass represented by M, specific heat capacity represented by C, and temperature change represented by delta T. You'll be asked to choose which variable you want to calculate by entering a number from 1 to 4. Pick 1, and the program proceeds into the right formula. But what if you type 5 or some random letter? No worries, this program's got your back. It instantly says invalid option with the choices that are correct, and the program will ask you if you want to try once more. If you type no, the program exits smoothly, and if you type yes, we're back to square one, ready to start again.
Let's say you entered number 1, which stands for calculating heat energy or Q. First, you'll be asked to choose your unit of mass, which is G for grams and kg for kilograms. If you type something else, SPeC will say invalid input and keep prompting you until you get it right. Let's go with grams this time. Now, let's have 400 as our mass and 0.759 as our specific heat value. At this point, there are two options for temperature change. If you know its value, enter it directly through the number 1. Let's say the temperature is 5. So, now we have 1,518 joules as our answer. However, if you don't know it, then enter the number 2, which needs the initial and final temperature to get the answer. The program will compute temperature change for you. Now, let's try giving initial is equals to 46 and final is equals to 86. The program calculates it and voila! You get Q is equals to 12,144 joules.
After displaying your result, SPeC will display, do you want to edit any value? Enter yes and pick the number you want to edit. Let us pick number 2 for mass and enter a new value like 30. The program recalculates everything and even show a specific heat classification based on your inputs. Once done, SPeC asks you if you want to calculate another variable. If you type no, it politely ends the program with a message. While if you type yes, the cycle begins again.
Let us enter option 2 to calculate mass. You'll input either G or kg followed by Q, specific heat, change in temperature, then answer the additional questions, and voila! Now you get a mass. Now let us calculate specific heat capacity through option number 3. Input the unit through G or kg, then mass followed by Q, change in Kelvin, then answer the 2 questions. Now the result is successful. Finally, let us enter number 4 to calculate temperature change. Similar to the previous steps, just give the desired unit followed by mass, then Q, specific heat, and answer yes or no in the questions to get the answer. Our program SPeC computes the rest for you.
Our code begins with a welcoming message that introduces the user to SPeC, the specific heat calculator. It also uses a loop structure which ensures that the program runs continuously. The code then displays a table that helps the user understand the 4 key variables. Moving on, we initialize a dictionary called verbs dict. The dictionary allows the program to easily update the variables.
Afterwards, users will choose which variable they would like to calculate. The program that asks the user to specify the heat they want to use per mass. When the user selects option 1, the program uses the formula Q is equals to M times T times delta T to calculate heat energy. If the user selects option 2, the program rearranges the formula to solve for mass. M is equals to Q divided by C times delta T. When the user selects option 3, the program applies the formula C is equals to Q divided by M times delta T to solve for specific heat capacity. If option 4 is selected, the program uses the formula delta T is equals to Q divided by M times C to calculate the temperature change. Moreover, if the user feels any input is incorrect, they are given the option to edit one of the variables by entering its corresponding number, which are 1 to 4.
After the calculation is complete, the program displays a summary table of all the results. Our program's special feature checks the value of C and classifies it into one of 3 categories: low specific heat, medium specific heat, or high specific heat. Once the user has completed a calculation, the program prompts them to decide whether to perform another calculation. When the user chooses to exit the program, a final message is displayed to thank them for using the specific heat calculator.
And that's wrap up our quick tour of SPeC, the specific heat capacity calculator.
We hope that this tool not only saves you time, but also helps you understand and apply thermodynamics more confidently.
Especially when dealing with heat transfer problems in subjects like physics and in chemical engineering.
Overall, whether you're a student or a professional working on lab reports or just trying to make sense of the formula,
We hope SPeC becomes a helpful companion in your academic and chemical engineering journey.